In this video, I'm going to be showing you guys how to analyze a graph, more particularly of a polynomial, and you're going to be writing out the intervals of increase and decrease and the turning points of the graph. This is very visual, so I want you to just kind of pay attention to the presentation that I put together. I'm going to be showing you exactly how it needs to be written and how it needs to, all these intervals need to be expressed, and the turning points you'll see is very easy. Alright, so an interval of increase is a portion of a polynomial graph where the y values are getting larger as the x values are getting larger. Essentially, the y values are getting bigger as the x values are getting bigger. Similarly, an interval of decrease is the same thing, but the y values are getting smaller as the x values are getting larger. The example I like to use is Ibn Mayo. He's a Tour de France cyclist who was really good at riding uphill, but he was really terrible at riding downhill. He just wasn't very brave when it came to going the speeds that those guys go downhill, but every time there was an uphill stage in the Tour, he tended to do very well. Alright, so in writing the intervals of increase and decrease, we have to identify the portions of the graph where Ibn would be riding his bike on it if it would be going uphill or downhill. So uphill, the dot's going to be green, and downhill, the dot is going to be red. Green obviously meaning go, because he's doing well, and downhill being red meaning slow down, stop. This is terrible driving advice, but I think it works for this graph. Alright, so he's going to start going downhill, and at this point here, he starts to go uphill. He starts to move up, which is a good thing for him. And then he starts going downhill in this next portion here. So this is the basic movement of this graph. Now, interval of decrease, we're talking about when the dot is red. So this first interval here, he's going down. The first thing he's doing is going down, and he stops going down at x equals 0. So we're always looking along the x-axis. So let me just show you that again. So on this x-axis here, he's going down, and I marked it with red. Alright, so that's where he stops going down on the x-axis. Alright, so at x equals 0, he stops going downhill. Alright, so he's going from negative infinity to 0, because as we see this arrow here, this graph technically is going on forever all the way to the left. A common mistake kids will make is they'll start it at negative 3, and I will assume some responsibility for that because I didn't put arrows on this graph, but since it's a polynomial, there's going to be arrows on it. Now he's going to start going uphill. Now we see it marking along the x-axis here, and it looks like it stops at x equals 4. So from 0 to 4, he's going uphill. So that's an interval of increase. And then at 4, he starts going down again. And as far as we know, he's just going to keep on going all the way down to positive infinity, which seems a little weird to say going down to positive infinity, but we're only looking along the x-axis. So from 4 to positive infinity. Alright, if you're still struggling with understanding what those intervals are, I would rewind the video and watch that part again. Now we only need to properly express the intervals. The first one we had was from negative infinity to 0. The way that we always write this is we use set builder notation, and we have x, and what this colon means is such that. So we're looking at the set of x such that negative infinity, we put the lower bound in there, which means the lowest value. 0 is much bigger than negative infinity, obviously. That's the upper bound. That's going to go to the right. And we just pop x in the middle with inequalities. That's all we got to do. Alright, so interval of increase, one of them, going all the way from negative infinity to 0, is denoted that way. Alright, the next one, from 0 to 4. Same thing, the set of x such that lower bound 0, upper bound 4, and then we pop the x in there with inequalities pointing towards the upper bound. Now when I say pointing towards, I don't mean the arrows, I mean the larger values are going towards the upper bound. So we would say x is greater than 0, and x is less than 4. So here we see I'm going to start at 0, start my climb. I'm going to go all the way up on the x-axis to 4. And that's an interval of increase. That's why that goes over there. Now we need to properly express the interval from 4 to infinity. Well, same thing. Set of x such that lower bound is 4. Infinity. Well, infinity. Oof. A little off center there. And the inequalities. Alright. So, same type of thing. I'm starting at x equals 4. And I'm going all the way to positive infinity on the x-axis. But I'm going downhill on the bike. So from 4 to infinity. And those are all the intervals of increase and decrease. That's all we have to do there. Turning points are different. Turning points are the coordinates of the portions of the graph where you're neither increasing nor decreasing. So it's changing from uphill to downhill. All right. So it's pretty obvious. Well, basically what we're looking at is when the red changes to green. Boom. That happens there. So we have that at the coordinates 0, 3. And we need the x coordinate here and the y coordinate. We need a specific spot. We can't just use x. So 0, 3 is a turning point, or 0, negative 3 rather. And then I'm green. And then I turn red. So my next one here is 4 and about 0.5. You may have to do some rounding at some point, but that's okay. Alright, so since the turning point is clearly the lowest, this one here, we would call this the relative minimum. Meaning that of all the turning points, this one is the lowest on the y-axis, right? So this one's way up here at 0.5. This one's down here at negative 3 on the y-axis. So we would say this is the relative minimum. And this one here is the highest. We would call this the relative maximum. If there's ever a tie, like there's two turning points and the one is they're both at negative 3 on the y-axis, I personally say that you would not call that a relative minimum at that point. Alright, so that's everything you need to know about interval of increase and interval of decrease and turning points. This is just a basic presentation. This is just a tool. So if you need to go back and rewind and kind of look at parts again so that you can see what's going on, I recommend that. This is a very visual unit, so I encourage you to keep paying attention to these visual aids.